Hi everybody, we're here for the episode 3 of OpenStack and Beyond. Shlomo Swidler is not with me today. He had to be traveling today and will join us on the next episode. With me is Florian Haas, and that most of you are probably aware of, and Arthur Berezin. I'll let the two of you introduce yourself.
All right, fair enough. Thanks, Nati. My name's Florian Haas. My specialties in the OpenStack community happen to be around high availability, distributed storage, and the deployment automation, and also cloud orchestration. I run a small professional services company called Spexa, and those three things, namely high availability, distributed storage, and OpenStack, are what we provide: architecture consulting, implementation services, performance tuning, optimization, troubleshooting, and training for. And I've been honored to be a member of the OpenStack Israel community for a couple of years now, and I always enjoy, as you know very well, Nati, meeting you and meeting my friends in Israel. So thank you very much for having me on the podcast today.
Excellent. And I would add that you've been able to also give a talk in Hebrew, or at least part of the talk in Hebrew.
I will never hear the end of that, will I? I think you're going to put that on my tombstone.
Exactly. I was thrilled just to listen to that, and I still have the recording. Arthur, I think you have some news to tell here to the forum here.
Yeah, so I've recently joined the Cloudify team as the product manager for Cloudify, and I previously came from Red Hat, where I was part of the product management team for OpenStack, and product owner for Heat, Keystone, Horizon, and HA as part of my role there.
Yeah, and both of you were giving a talk on the OpenStack event around high availability. What was the difference between the talks that each one of you gave? I mean, what was your theme of the talk, Arthur, and then we can move to Florian?
Mm-hmm. Yeah, so I mainly gave an overview of where we stand today and what are general approaches to build highly available controllers. Obviously, there is pretty good knowledge we gain as a community in how we build OpenStack in a highly available environment, highly available configuration. And obviously, there are some pitfalls and some services that are still not, it would be harder to make them highly available. So I just touched some of those areas as well into what to look into when you're building such an environment.
And Florian, I've seen that you've been given talk about availability for quite some time, since 2012. What was the difference between each of the talks that you gave and kind of the broad spectrum of the things that you tried to cover there?
Well, what I've been doing over the last few OpenStack summits is a bit of an overview of sort of the current state of high availability in OpenStack from an infrastructure deployment perspective, as in what are the tools that the OpenStack community itself and OpenStack product vendors make available to deploy OpenStack in a highly available fashion. For my OpenStack Israel talk this time around, I focused more on the orchestration, that is the automated deployment of virtual environments within OpenStack, where we do have a certain amount of HA capability that is offered through the OpenStack orchestration service or OpenStack Heat. And then in another talk that I did effectively half a week before OpenStack Israel at OpenStack Dach in Berlin, Germany, I also focused on deployment automation of an OpenStack cloud with the various tools that are available from various vendors, and also their spin on high availability, where we see a number of items that really have emerged sort of as a de facto standard, basically emerged as a best practice that all of the OpenStack vendors adhere to, and hopefully their customers as well. And we also see some minor, albeit sometimes relatively important differences between the individual implementations.
That's excellent, and that brings me to the kind of the first question here in terms of the current state of availability in OpenStack. And first of all, maybe we should clarify what we mean by availability of OpenStack. We basically mean the availability of the elements that comprises the infrastructure in OpenStack. Is that the right way to define it?
Sure. Yeah, that's that's one aspect of high availability in OpenStack, where OpenStack is actually relatively advanced. We've got most of the bases covered at this point. So that's when we talk about the actual OpenStack infrastructure services, starting with the services that basically underpin OpenStack but are not part of the OpenStack code base proper, such as, for example, our message bus or relational database management system. And then moving on to individual control services like schedulers and the like, and then the actual RESTful APIs. So that's all infrastructure, and another important part of infrastructure high availability there is the availability of network gateways. And then we have a whole different set of topics that are related effectively to the high availability of our compute infrastructure. And as far as that is concerned, we're not quite at that point where some of, or maybe a significant portion of the OpenStack community would want us to be. I'm not sure what Arthur's thoughts are on this, but I think we're fairly in agreement on this one, aren't we?
Yeah, and it's been uncovered and explored as we speak as part of the Liberty cycle. Basically, we basically finished on focusing on making the services themselves highly available. Obviously, there are some gaps around that still, but the main topics or the main pain points are mostly covered. So there was some noise there. Yeah, so the main pain points are mostly covered, and then we're starting to explore on how to make the actual virtual instances highly available, and basically making sure that they're highly available as well.
I see. So in that context, like if I try to again go through the list of services there, and especially if I stay in the context of what's the current status of the OpenStack one, Arthur, would you say that the current version of OpenStack is highly available and now it becomes more of a question on how you configure things, or is it still things that need to be done outside of the product line to actually make it highly available?
Yeah, so at the moment, the services themselves, or the services that are delivered or offered by the upstream code base, are still not highly available, and it's a question of the deployment tool that you use, or deployment method that you use to build a highly available OpenStack. So again, from a code base, the projects themselves are not solving the whole problem, where some projects are focusing on a specific application area where the services themselves are stateful. For stateless services, this is still a matter of how you deploy them, and which deployment tools or methods you use to deploy the environment.
And I'd like to add to that, perhaps if I may, that this is something that all of the OpenStack vendors have understood as to be a necessity and a requirement. So therefore, from any OpenStack vendor that you can buy an OpenStack product from now, it will come with a highly available deployment option. And with a deployment option that in fact aims to take much of the complexity of a highly available deployment out of your hands and putting it into the hands of an orchestration layer. And if we go to the products, through the products individually, they all have different ways of resolving that, but they all do it. And with RelOSP, that's OpenStack product, you do that with an orchestration or a deployment orchestration engine that is built around Foreman and Puppet. With SUSE, you do that with Crowbar and Chef. With Ubuntu, you do that with Juju, and on Rackspace Private Cloud, you do it with Ansible. But basically, the underlying technologies are effectively all the same. They're being used in slightly different fashions, but overall, we're building these highly available infrastructure services all in the same way. There's always some form of load balancer involved, typically HA proxy. There's always some sort of high availability manager involved, typically Pacemaker. There's always some sort of database replication involved, typically MySQL and Galera. And so we're seeing these emerging best practices that all of the vendors effectively have adopted and have made very easy to deploy. So maybe we needn't really worry that much anymore about the fact that upstream doesn't care so much about actually providing the high availability, but rather making or keeping the services in such a way that they can be made highly available in a relatively easy fashion. Who knows, maybe we're going to see a rewrite of some key services at some point down the road, say, for example, in the context of systemd, fleet, and etcd, or something of that nature.
So,
yes.
so a question on that regard, again, if I'm listening to this talk and I want to, again, understand what the gotcha is, what are not, if you list the list of services, would you be able to categorize them based on the level of availability, meaning that, you know, maybe Nova has 1 degree of availability and, you know, other service, Cinder, whatever, is less highly available than the Nova, or vice versa? What would you respond to that?
Yeah, so I guess we could categorize each and every service and basically specify. I'm not sure if the right word is how highly available that is, but which portions and which and what level of service we can that specific project can provide. So, for example, we know today that we still have a gap with Cinder, where Cinder volume still has to be configured in an active-passive configuration due to some race conditions possible in the environment, and obviously consistency of the data is the most critical thing when we talk about data. We also know that we don't have any specific watchdogs for the virtual machines with Nova, where we can make all the services around Nova highly available, for example, the scheduler, the API, etc. But nothing to date watches the VMs themselves, and these are still the areas that we're still exploring within the project itself.
I see.
Yeah, I'd like to add to that, if I may. As Arthur has pointed out, there are certain services that are inherently stateless, so we can effectively deploy as many of them as we want, and high availability is relatively trivial. There are services that are stateful, which we currently can deploy only in an active-passive configuration. But as of this point, you can't. When I say services, I actually mean individual microservices of certain OpenStack. A certain OpenStack component. So you can't really say, oh, you can do this with Nova, but you can't do this with Neutron, or you can't do this with Cinder. But for example, if you take a look at Cinder, one such example is you can effectively have as many API services or as many API instances as you want, and they're inherently stateless. But you can have multiple Cinder volume services, and that typically means something else, which means that you typically have several services that might talk to different backends. And then for all of that, you typically keep your Cinder scheduler highly available in an active-passive fashion. So there's individual HA considerations for specific microservices in specific OpenStack components. But again, and this is something where I think that the OpenStack vendors, the Red Hats, the SUSEs, the Canonicals, the Rackspaces in the community, can really add value, because what they can do with their engineering teams, with their QE teams, QA teams, whatever they're called, is that they can define these best practices for deployment and then actually put them into their automation schemes, their deployment automation schemes, whether those are Crowbar and check-based, or Puppet and Foreman-based, or Ansible-based, or whichever. And they make this available to their customers and or the community at large. So that takes a lot of that complexity out of the picture.
Yeah, so I'd like to add to that another thing. So as Florian mentioned, obviously each vendor has its own reference implementation, basically a way to orchestrate an automated deployment of such reference architecture. But I'd like to point out also that these deployments are opinionated, and there are some minor differences between them and minor choices that each vendor has chosen. So when a customer looks into actual deploying such environments, I think it's also important to look into differences that each of the solutions offers, and basically chooses as part of its reference implementation. So, for example, if I look at Red Hat's implementation, Red Hat is highly recommending to use a fencing mechanism, for example, for data consistency and for state consistency, where other vendors are not requiring that, or not as strongly recommending on these this configuration. So when you basically choose and look into the high availability options that each vendor offers, I think it's also important to look at the details and dive into the actual reference architecture that's going to be deployed.
Yeah, just for the record, SUSE is just as vocal about the necessity of fencing when it comes to an HA platform. But Arthur, I believe you are correct that, for example, in the Ubuntu or in the Mirantis product literature or documentation, you don't find quite as strong a recommendation for that. I would certainly agree that fencing is a necessity in a highly available environment, and it's something that in the HA community we've effectively been doing that way for a number of years. But you're correct that Red Hat obviously emphasizes it very strongly. SUSE does as well. The others maybe not so much.
I want to just 1 second here. I want to come back to that point because I think we're touching an interesting point here. Just want to recap for the audience here what we just basically said. So I think that Florian, if I summarize, at least from the talk that I heard in 2012. Where a lot of the pieces in the upstream didn't exist in terms of availability, or at least for most of the services. We're at the point in which a lot of the capabilities for availability is now part of upstream, which means that the OpenStack community is dealing with that issue and trying to address it. Having said that, if you want to, kind of a prepackaged solution with the orchestration or pre-baked orchestration, which by definition would be slightly opinionated or highly opinionated. The distro are probably doing a better job there, so that will get you faster in the right path in terms of availability. There are still differences between the approaches between the different vendors in terms of the level of availability and the approach to availability that I think we just started to talk between the Red Hat model and probably Mirantis and Ubuntu. And in that context, I think, Arthur, you raised a point, and Florian, I think, responded to that. I'm not sure that I'm clear about the differences. I mean, does that mean that in terms of availability, Red Hat is taking more strict approach toward consistency, and the others are less? Is that a trade-off between, if you're all familiar with the cup theory and consistent availability and partition tolerance, there's always a trade-off between all those properties. I mean, the different approaches are related to the different choices between those trade-offs, or is it something else?
So yeah, I'll just, the short answer to that is yes, but obviously there are some additional constraints or bonuses, if you may. So for example, Red Hat obviously is using already existing products Red Hat offers. So HA Proxy and Pacemaker are already products that Red Hat has been offering for quite a while now, and gain a lot of experience in running environments with these tools. So obviously, the way Red Hat is built, its HA solution is basically built on top of the experience it gained with using those tools. So those opinions are coming from that direction. So it's a question of what tools are already in your tool set that you would like to use, and which tools are you adding to that, and what are the default choices that you make when you build and automate these environments.
I see. And in terms of the consistency and availability, Florian, what are the common trade-offs that you see in the availability approach between the different solutions?
Sure.
Do you see any trade-off, or is it all joined? Yep.
Let me just address this with a specific example. We have a relatively universal way across most OpenStack services to basically detect whether a specific microservice is up and responding or it's not. And that is true for Nova services, Cinder services, Neutron agents, and so forth. Which basically means, or the way this basically works, is more or less like a dead man switch, where a specific microservice reports on the AMQP message bus, typically on RabbitMQ, and talks to an API service and says, hello, I'm still alive. And if that dead end switch isn't pressed within a specific amount of, or a configurable amount of time, typically 60 seconds, then the system is considered dead, or that microservice is considered dead. Now that is, of course, a very, very weak coupling of services, which is sort of in line with the basic tenet of accepting eventual consistency where necessary, and with everything being distributed and everything being horizontally scalable. However, things become thorny and hairy when you mistake this approach for a strongly consistent one. If you have, for example, a neutron L3 agent that hasn't reported for 50 seconds, then all that you actually know about it is that it hasn't reported for 50 seconds. That doesn't necessarily mean it's dead. And even if it hasn't reported for 65 seconds, that doesn't necessarily mean it's dead. It could not be able to communicate on the RabbitMQ message bus. The network that we push our AMQP traffic over could simply be congested. The system could be overloaded and simply be unable to send those AMQP messages on the wire, but it needn't necessarily be dead. Now, if you then basically were to recover, say, for example, virtual routers on a different network node, then you might end up with all sorts of interesting situations with, say, for example, duplicate IP addresses and whatnot. And so, therefore, you can't really make that assumption that you have a tightly and strongly coupled system based on a system that is effectively relatively weakly coupled. And so that's one example where sort of the added benefit of what Arthur just mentioned can come in, where you can have sort of an engineering team that has long-term experience, like the teams at SUSE certainly do, and like the teams at Red Hat certainly do, and in other places as well, that can basically take that experience that they've had from several years of building HA systems and then provide that to OpenStack as well. Because it is perfectly fine for OpenStack to say, all right, this is the design approach that we chose. It is a loosely coupled system. But then if you want to make such a system truly highly available, there might be a few things that the vendors may still need to do for you as part of their implementation.
So I think you're touching an interesting point there in terms of how do you detect failure and how do you distinguish between a false alarm versus a real failure. And you mentioned, I think, one example in the neutron side on the side effect of those type of detection. Do we have any consistent way to detect failure across the services, or each service has its own way to detect failure within OpenStack?
Well, right now we have an established best practice. I'm actually not sure if there was ever an explicit consensus to do it this way. But what we're seeing is effectively what I described earlier, which is we have a system effectively checking in on AMQP on the message bus during a prescribed time frame. If it doesn't do so, then the system is considered down. That is not really a consistent way of determining service availability. There have been a few things that have been proposed from people inside and outside the OpenStack community to address these things. Of course, we could consider things like an automated service catalog with service discovery, which is something that you might be able to build around, say, console or FCP or what have you. But this is simply owed to, well, effectively the necessity of how long OpenStack has been around. Many of these services simply were not available or were not stable at the time when OpenStack needed them. So pointing the finger at OpenStack right now and saying, oh my God, it's terrible that OpenStack did it this way, how could they? That's kind of not really fair. But that said, we now have some of that technology available, and we might see some of those changes coming into OpenStack at some point, which, by the way, touches upon other issues as well. Because if you have, say, for example, a service catalog with automatic service discovery, then you could also do away with the service catalog in Keystone. But then we're sort of into relatively profound and fundamental changes. And we need to simply acknowledge the fact that, contrary to 4 years ago, OpenStack is now a very, very widely deployed production deployed system, and these changes simply take time, and they take deliberation, and they now also involve a lot more people than they used to.
I see. And Arthur, in terms of the again this potential false alarm, how do you Red Hat deal with that? I mean, you mentioned HA proxy, but even for stateless service, if one of the services died, the normal behavior would be fairly easy. I'll just route it to another server. But in a stateful service, there is the you mentioned the master election process. Obviously, in master election, if there is a false alarm, then I switch over to a master, but then the other master just comes back to live, then I obviously can end up with the split brain scenario where I have two masters. How do you avoid something like that?
Yeah, so as Florian mentioned, there are some of the services, and Neutron is a good example for that are stateful, meaning they know they have a state that the service itself, when it's running, it knows which service it holds the data within the service that is the current active service. Now you have mechanisms that are external, that are monitoring the services themselves, and Neutron is a good example for service that you have an internal monitoring system that is actually aware of which service holds which server holds the master node. So, for example, Neutron L3 agent is aware of which servers, which nodes are running the L3 agent, and is capable of hopping and balancing the active running server. Where in addition to that, you also have the external monitoring system for the external cloud, external availability management system that monitors the service that is fully active and it's running and it's providing service. So basically, you have that as another layer of protection. So once it doesn't respond for a certain amount of time, basically the external service is able to restart the service. And if the restarting of the service fails, you would restart the whole node to make sure it doesn't hold the active node. And once the failed node is being restarted, you can know for sure that you have only one running master holding the service.
Okay, so that's by the fact that you're using both external monitoring and internal monitoring, and that kind of gives you a way to detect, if there's a two-master scenario or potentially two-master scenario.
Exactly.
Okay, that brings me to kind of more the operational questions around that, and I'll get to a few other questions with regard to the different approaches on solutions. One of the common problem of dealing with failures in general, and I think availability happens to be one of those failures, is the perfect storm, if you like, scenario where one of the node fails and that starts to sends messages all over the place, and a lot of services are being affected of that, and then that creates a ripple effect. Florian, how do you handle something like that? What are the best practices around that?
That's a bit of a broad question. Can you clarify that?
Yeah, I mean, how do you avoid the perfect storm? Meaning that the one failure leads to all the many logs and many alerts that then becomes in itself a problem that creates a failure scenario.
So this is something that's a relatively standard approach in building highly available systems, basically called avoiding a Byzantine failure, a failure that causes yet another failure, causes yet another failure, and so forth, which basically boils down to number one, you want to eliminate your single points of failure, where a single point of failure is defined as something where one single independent failure can bring the system down, and that includes the cascading failures that you described. So if you're building a system where one system or where one component can not bring the system down immediately, but that one component fails, and that causes another failure, that causes another failure, that causes another failure, and that ultimately brings the system down. if you build a system like that, then that system is not highly available. It's as simple as that. But the way that you actually defend against that is to address every single potential single point of failure in your system. You eradicate them one by one, and then you apply a very, very strong distributed integration testing to make sure that it in fact does what you expect it to do and avoids what you expect it to avoid. And again, at the risk of repeating myself, this is one of those things where we can see real value added to the OpenStack community by developers and DevOps and engineering people and QA/QB people working for vendors, as opposed to necessarily, spending most of their time upstream.
Yeah, I definitely agree with Florian here. Obviously, a good design would help avoiding such storm environments, such storm cases where you have service failing by service because they're all dependent on one on top of the other. And definitely, having a standard solution coming from a vendor that is being fully tested and certified, it's definitely good to have.
And in case of the, again, let's say that I did discover a failure, and usually the practice would be to, move to another alternative service, but how do I create back the failed service? I mean, is there a way to make sure that I have someone that will spawn up that new service that it just failed?
Yeah, so it's a matter of automation of recovery, which also should be part of the overall solution. So once a service has failed, you have an automated procedure of bringing that service up and basically making sure that the new host or the new service that is being brought up is fully functional, and that's part of the clustering mechanism that should be monitoring the service itself.
Yeah, so again, the reason why I'm asking that, because I think that's kind of an easy, well, I wouldn't say easy, but at least something that at the application level, I can see that happening, especially in a cloud environment where usually it's a matter of spinning up a new VM and configuring it correctly. But in the infrastructure itself, which is the cloud itself, that's not often that easy because it cannot easily spawn a VM if it's responsible to manage those VMs itself. So it's kind of one level down to actually deal with those problems. So the question is, what is that provisioning system, and where do I find that extra resources? How does that down at the infrastructure level?
Well, the provisioning system is the one that you use to deploy your OpenStack, whether that's Foreman and Puppet or Jeff and Crowbar or Ansible, whichever. The system that actually makes this happen effectively is, well, a high availability clustering service. And here what we're seeing is a general consensus. Arthur, correct me if I'm wrong on this one, but I think we're seeing a general consensus of the way that how we're building these highly available services, which is we have multiple instances of these services. We put them behind an HA proxy. HA proxy is very good at detecting backend failure and ensuring failover. And then we use the Coruscant pacemaker high availability cluster to, number one, provide high availability for HA proxy itself, because it doesn't help to have a load balancer in front of a bunch of distributed services and not having the load balancer highly available, because then you've only moved your single point of failure elsewhere. So we use the Coruscant pacemaker stack to maintain availability for HA proxy, to shift around virtual IP addresses so we can make sure that any client of whatever service that we're talking about always has an endpoint to talk to. And then we also use the pacemaker cluster stack to maintain the availability for those services that we currently can run sensibly only in an active passive fashion, where a horizontal scalability for load balancing is really a necessity. So that's effectively the stack. It's pacemaker, Coruscant, HA proxy, and as for relational database management system high availability, the de facto standard is more or less MySQL with Galera, with one exception, which is SUSE. And SUSE built their SUSE OpenStack Cloud product on a Postgres basis as far as the RDBMS is concerned, but that's effectively a technicality.
So, yeah, definitely. I would like to also bring another point that I think, Nati, you brought up, and I think it's important to mention here. So at the moment, provisioning of additional services, for example, you have 2 failed services and you would like to deploy 2 additional nodes to host a specific service. To this point, such operations are still done manually and they're not yet fully automated. So there's no awareness of deploying additional nodes and additional instances of the same OpenStack service, and this is still something that is done manually, basically.
Good. So I think this is where I want to at least recap what we just discussed. So I think on the monitoring side, the way we should handle availability of the monitoring itself, meaning not getting a false alarm, is by having more than one monitoring system, one internal, one external, like in the case of Neutron, and the consolidation between the two should give us a relatively good answer in terms of detecting false alarms between the 2 monitoring systems. The other thing that we discussed is the perfect storm, and I think Florian, you mentioned, and also Arthur, that first of all, if we design the system so that they wouldn't be dependent too much on one another, would minimize the case in which we have a ripple effect between one failure leading to another failure, leading to another failure, and in that case, that will create that type of perfect storm. But that's also a responsibility of the way we handle logging and other things, so that when such a thing happened, we'll be able to handle that. And I'm not sure that there is a better answer other than try to minimize it, and that's probably the maximum that you could get. The other point that I think we just touched is how do we handle, or how do we recover from failures once one failure happened. So obviously the immediate solution would be to move to the alternate node, but that means that we now exposed, meaning that we have less available nodes in the system at the point of failure. And I think that the answer is that that's one, vendor specific, and second, it's done mostly manual, if I got the summary correctly, through manual intervention. And again, the difference is that in the infrastructure level, we don't have the ability to assume that capacity management can be done just by a call of an API, because someone needs to actually bring that physical resources up. And it's not something that is, hidden in a sort of a virtual pool. Is that a good summary?
Yeah, I believe so. Yeah, so we're basically to recover from a service that's already being deployed. That's something that is done automatically, but basically to deploy additional nodes to handle additional loads, for example, or if 2 nodes are completely are in complete failure and are not able to recover, and you would like to add more resources to that pool, you would have to do that manually.
Yeah, so if I kind of add to that point, and I think that leads me to the next questions, it sounds to me like availability, as I would imagine, is a fairly complex topic. So one thing that I think, Florian, you mentioned, that's not necessarily an area that you want to deal with yourself, giving all the different moving parts that you have to think of and deal with, and that's probably the right approach would be to use experts in that, obviously those that comes with the distribution. And on top of that, are there any things in OpenStack, Florian?
Just for the record, I personally don't mind dealing with HA solutions and building them, but I do concur that it is, and I've had the pleasure to take a deep technical look at most of these solutions. And what the individual vendors have come up with largely makes the best of sense, and it's absolutely it's absolutely a good thing that we have these best practices out there. And it's also part of the reason why I always implore people to, unless they are a company of the size of, say, HP or Rackspace, or any other company that has a significant number of people actually being able to work full time on OpenStack, if you're any smaller than that, then it's always a good thing to basically go with the best practices that your vendor makes available, rather than roll your own, for a variety of reasons. You're gonna be quicker at rolling out your distribution. It's going to be less in terms of cost. It's going to be much more streamlined and so forth. So,
and I also have a neck to hang or to strangle if something happens and it's not me to blame. So that's another.
Yes, there is a throat to choke. Yeah.
That's the right term that I was looking for. So thanks, Florian.
To add just one more sentence to what Florian just mentioned. So I think it also important to understand the expected behavior of such systems. I've run into some cases where customers or users were we're not on top of what would be the expected behavior when specific failures occur. So I think it is important. Obviously it would be good to rely on existing reference architectures, but it would be also great to dive into the details of such the behaviors that are basically coming from such environments, and basically to fine tune them as you need. For example, there are specific cases where you expect a recovery in specific time frame. For example, and if that doesn't happen, you would like the flow to occur, for example, such cases. So it's important to dive into the details as well, if you have resources for that. So
great. So I think that leads me to kind of a question to both of you. If things are improving, what should we expect in Liberty? Should we expect any significant improvement in the area of availability in OpenStack? Florian?
So in terms of infrastructure and service HA, we're pretty much there. We certainly have systems which some people will identify as non-perfect. I will agree with them not being perfect, but they're as good as what we can get with the currently available technology, as far as it is properly integratable with OpenStack. We have seen fairly significant improvements in HA routers, in highly available virtual routers between the last two releases. Really, we got that feature experimentally in Juno, and it has now significantly improved in Gila. The one thing that we're still missing out on at this point, and we'll see how far we get there in Liberty, and maybe Arthur has a few additional bits and pieces of information to share there, is high availability on the compute side at the actual virtual machine and the guest level. Arthur?
Yeah, so again, there's been some research done in the Liberty cycle for providing HA for the instances themselves, and basically using KVM watchdogs to monitor the state of the machines, of the virtual machines. This is one part of that, and the second part is basically, and this is the general approach at the moment, is basically to use a pacemaker remote, which basically is not a full pacemaker cluster on the compute nodes, rather an agent that basically is capable of providing specific inputs from that node to existing pacemaker cluster. And basically take some actions based on the inputs coming from that. So that's on the Neutron VMHA side. But I believe that there obviously I think other services will start looking into that as well. For example, additional services, for example, heat and ceilometer, and additional more advanced services will start being aware of that they're being deployed in multiple nodes that are being deployed they are being deployed in multiple nodes, and we'll be able to provide such features as well.
So what about the ironic that has been announced in the last Vancouver summit? How does that help the culture?
Yeah, so Ironic is being part of actually Ironic is being now a more centric part of OpenStack to deploy OpenStack and is part of the Tuskar 000 deployment method for OpenStack. So again, it does bring some more complexities since it provides another way to provision OpenStack services, but yeah.
So should I consider that as kind of an alternative to this, or is it still software and covering what the distro provides today?
Could you repeat that, Nati?
Yeah, I was asking if I use Ironic today, I mean, isn't that kind of replacing a lot of the things that I would get from a distro? Should I expect that a lot of the automation and things will be dealt at that layer?
Yeah, so I can I can speak of Red Hat's behalf. Basically, Ironic and Tuskar and 000 are becoming the standard deployment tool with the OSP 7 that is coming out, I believe, next month. So that's basically becoming the way to deploy OpenStack, where still the OpenStack Puppet modules that are being used to deploy the reference architecture for the services themselves, they are still being used. So the underlying tools for deployments are changing, but the reference architecture and the deployment modules for the Puppet deployment modules for OpenStack are still remaining the same.
Hey, Florian, anything to add on that that you got from your end?
I can't really comment on sort of the future impact that Ironic may have in this space, because as it happens, my crystal ball just fell off the disk and shattered. But we'll see. So as of right now, there is still, I think there's a fairly strong sentiment within the OpenStack community to use relatively conservative, relatively well-established deployment tools for deploying an OpenStack infrastructure, such as Puppet, Chef, Ansible, and the like. And from what I have seen, there is a bit of hesitation to go with something like Ironic to effectively completely change the deployment approach. That doesn't mean, however, that can't happen. And I think that what Ironic faces here is fairly stiff competition from the more established solutions. But who knows? Maybe it's going to outpace them and outrun them and outperform them within a very short time frame. And then maybe we'll see a change there. But all of that is really speculation. So we'll just see what the future holds there.
Excellent. Now, if I'm deploying application on OpenStack, how would all the things that we discussed here right now, other than the part that if my OpenStack is not running, then I'm going to be affected with that. How am I going to be affected of this availability structure? Is there any common best practices to use the same underlying mechanism for availability of the infrastructure in the application? Is that two separate worlds, or should I keep it as two separate worlds, meaning the way I'm handling availability for my application, the way I'm dealing with the availability of my infrastructure? What's your view on that?
Yeah, so obviously OpenStack, has been started off where you deploy, where you basically write your application to be cloud aware and to be fault tolerant. So, when you have one instance failing, doesn't matter, you just, automatically provision or spin up a few additional instances of the same application. This is with regards to cloud aware or cloud native applications, where and in cases where you wanna deploy more traditional applications, you would still have to wait for the infrastructure to take care of the availability of their virtual machines themselves.
So I'd like to add to that, because it basically brings me right back to, I think, the very first HA discussion that I was ever part of at an OpenStack Summit in San Francisco several years ago, which is there are two types of applications that you can see in the cloud, or two types of uses that you might have for a cloud. If you are deploying, if you're building a cloud-ready, extremely scalable, extremely distributed application. Say you're building the next Twitter, or the next thing that is sort of on the scale of Twitter, and that's what you want to use your cloud infrastructure for, then it's very typical that you have a very small number of applications that you typically manage and that you have full engineering control over. So that's the classic case of sort of the cloudy startup. But there's a whole other category of users of an OpenStack cloud, and namely the ones that are basically looking to OpenStack as a modern way of re-architecting the data center. And there the situation is wildly different. You don't have one or maybe a handful of applications. It's relatively typical for an enterprise operations team to manage dozens, if not hundreds, or in large organizations, maybe even thousands of applications that they typically have zero engineering control over. So while you can say in the first case, okay, well, just re-engineer your application such that it's inherently highly available and cloud-ready and can always take, say, for example, a 20% failure rate, or 20% of the VMs can always die at any given time, and the application still continues to exist. In the enterprise use case, you simply don't have that. So what you need to do there, what you need to provide in order to keep that part of the user base happy, is to have the ability to say, here's a VM and here's a checkbox that says, okay, this thing is meant to be highly available. This thing is meant to survive any kind of hardware or software failure. Do your utmost to keep this thing highly available. And we're simply not there yet for virtual machines in Nova at this point. We're there right now, for example, for virtual routers. That is something that has been added to the feature set of Neutron in the Juno cycle. But we're not there yet for virtual machines. And this is something that, for example, VMware has got right. There you've got that option to simply keep a virtual machine highly available. This is something that's available in Zen Server and a variety of other products. And that's simply something that OpenStack doesn't have at this point. And I will not consider the OpenStack feature set complete until we have that, but we are making progress toward that goal. Slowly but surely, and it is, as I said, it's a project that has achieved a certain degree of complexity, and therefore certainly a certain amount of, to use a terrible word, inertia. But yeah, that's the way it goes. And as other people have been saying in this regard, is that you might point your finger at certain things that OpenStack doesn't do very well. But you can then look at other available open source cloud implementations, and you don't have anything to point at because there's simply no code there in that space that would cover that kind of functionality at all.
Yeah. So to add to that, and I think the good news about that is that it seems like in the last and upcoming cycles, getting a higher priority to be solved, and it seems like more and more people are getting into solving these pain points. So this is a really good time to expect in the next releases for these topics to be solved.
Okay, so guys, we have 2 minutes to conclude here, and I feel that I have a lot of questions that are still things that I wanted to discuss on this very interesting topic, like how capability structure affect, the design for scalability and for upgrades, and the tools that I should use and not use in that context, or things of that line. But obviously, we'll not be able to cover that. I hope that we'll be able to put a link to both of your talks that I think are covering a large part of those, at least part of those questions in your talk. I would also mention one other thing that Florian, you reminded me when you mentioned the availability of the VM, is that this is how we actually, I think, learned to know you. I remember your comment back in 2013, I think it was, when you pointed out the fact that we're missing the vMotion capabilities, and that was kind of the first OpenStack summit in Israel that I think you raise yourself above the rest of the audience there and make a note. So something good came out of that lack of good light, and here we are. So anyway, let's do some concluding remarks, Florian and Arthur.
Well, as far as concluding remarks are concerned, it's always difficult to put concluding remarks to a journey that is still ongoing, which is certainly the case for enterprise-grade high availability in OpenStack. But on the other hand, it's a good thing that we're not quite there yet, because it simply means that we still have work to do and we have things to improve on. We've come a long way already. We're not quite there where I think most of OpenStack's users would want OpenStack to be, but I'm confident that we will eventually get there.
Yeah, I definitely agree with that. I remember, Florian, one of your opening slides in one of your earlier talks was, HA, are we there yet? So we're close. We're really, really close, and for most use cases, we're there. There's still some gaps that we're still working on, but we're close.
And I would say that the other good news for that is that it's still going to pay our salary and keep ourselves busy. So there is this effect as well in that regard. So anyway, thank you guys very much for this interesting talk. Again, I personally enjoyed it. I hope you do as well, and definitely the audience. We'll finish the third episode right now, and hopefully the next one we'll have Shlomo joining us again. So thank you all.
Thank you,
guys.
guys.
It's been a pleasure. Thank you.